Good morning, Algebra 2 CP students. Hopefully you are having a fantastic day so far. You may notice that the camera angle on this video is a little different than the previous ones. What happened was I unfortunately left my camera at school, my normal webcam. I was so mad about it. It's probably sitting on my desk right now. I knew I had to do videos today, so we had to improvise a little bit. And what I have is my phone currently duct taped to my computer monitor, and I'm using the camera on my phone and casting it to my computer to serve as the webcam to accompany this video. Had to get really creative, dive into some pretty crazy tech, but we got it working, meaning that nothing is going to stop us from getting some Algebra 2 done today. So I appreciate you bearing with the less than flattering camera angle showing 5 chins here, but that's okay. We're going to get some Algebra 2 done, and we're going to have a great time doing it. Today, what we're going to be doing is writing quadratic functions given information, meaning that we're almost going to be going backwards, whereas before I asked you to sketch a graph of this particular function and you'd have to go through all the steps to do so. And now we're going to say, hey, if a quadratic function has, say, this vertex and goes through this point, could you actually tell me what that function is? And we'll talk about how to do that today. One thing I wanted to do first was just to show you an example of how we graph in vertex form. Everything we do today is going to be in vertex form. So, I just wanted to make sure it's worthwhile to review to make sure you understand the process going forwards so that today when we do the process going backwards, it makes sense. To start with something in vertex form, the reason it's called vertex form is because it more or less just gives you the vertex right out of the gate. We would say here that the vertex is h comma k. So the fact that we see x minus 3 inside these parentheses means the x-coordinate of the vertex is positive 3. And the k just translates directly to the y-coordinate of the vertex. It would be negative 5. So our parabola here would start at 3 comma, sorry, that camera shook just a little bit there, 3 comma negative 5, which is here. And then from there, we create our chart. The vertex would be right in the center. So we structure our chart by going 2 to the left and 2 to the right. Take these values, plug them in, and see what we get. I chose to do 2 and 1, but you could do 4 and 5. Whichever half you choose is fine. Plug them in, this is what we get. Plug it in, this is what we get. Sketch them on the graph, and then reflect over to the other side due to symmetry. Right? After we do that, we're able to sketch our graph and then describe it. The domain of this parabola is all real numbers. It goes forever to the left and forever to the right. Every parabola does, whether it's facing up or down. The range of the parabola is negative 5 to infinity. The lowest it goes is negative 5, and it goes up forever. The axis of symmetry is x equals 3. That's the vertical line, remember, that sort of cuts this parabola in half, and it always goes through the x-coordinate of the vertex. So something important to keep in mind. Remember, the range corresponds to the y-coordinate of the vertex, because the vertex's height is going to tell us how high or how low the parabola goes at its maximum or minimum point. Speaking of maximum and minimum, this parabola has a minimum of f of x equals negative 5, because that's the lowest that this parabola will ever go, down to negative 5. And the end behavior, it's going up on both sides, so we'd say as x approaches negative infinity, f of x approaches positive infinity. As we go to the left, the graph goes up. Same thing on the right side. As we go to the right, the graph goes up. All right? So let's take a look now, or at least let's try to, see how we can go backwards. What if I give you some information about the graph? Can we actually create it ourselves? Let's take a look. Ready? Consider something kind of like this. What if I told you that I have a quadratic function that has a vertex at the point 1 comma negative 5, and it passes through the point of negative 1 comma 7. Could you actually make a quadratic equation in which that's the case? Like I said, well, we can. Like I said, we are going to do everything in vertex form because it is much easier than standard form. If I asked you to do this in standard form, you could actually just build it in vertex form and then convert it to standard form based on what we did yesterday. So it's certainly not an impossible question, but for our purposes, we'll do everything in vertex form. That's f of x equals a times x minus h squared plus k. So The fact that I'm given the vertex is a key piece of information. In fact, you might have thought of the fact that, hey, if I know what my vertex is, then I know what my horizontal shift and vertical shift is, so at least I can get that far, right? And you're absolutely right. That's exactly tying into the conversion from yesterday and how that all worked out. So I'd say, well, if my x-coordinate of the vertex is 1, then that has to go in for h. And if my y-coordinate of the vertex is -5, then that would most certainly have to go in for k. So we could start by building our function to say, let's use that vertex information to say we have f of x is equal to a times x minus 1 squared minus 5. And that's really almost all of the way there. The last piece of information, though, that we don't have is a. And so you might be asking, how do we get a based on this information? Well, something that's of particular value is the fact that when I'm given a coordinate, that means I'm given a value for x and I'm given a value for y. That satisfies this function, or in other words, that fits into this function. So what I can do is I can take this value, plug it in for x, take this value, plug it in for y, or f of x, whatever the function yields or outputs, and then solve for a. And that would allow me to build my function. So after applying the information about the vertex, I could say, well, let's use our point and say that 7, the y-coordinate, should equal some unknown a, which we're about to find, times x, -1, minus 1 squared minus 5. And then this is just a little bit of algebra that we can do to figure out what a is actually equal to. All right, does that make sense? We're substituting this value for x, this -1, just went in right where x was, and this 7 just went in for f of x, or in other words, y. So let's see what this is actually going to look like. We'd say here that 7 is equal to a times -1 minus 1 is -2, squared is 4, so a times 4 minus 5. Maybe to write that in a little bit more of a familiar format, we can say 7 is equal to 4a minus 5. And now this is just an Algebra 1 two-step equation that we should be more than comfortable with. Solve for a by adding 5 on both sides. That gives us 12 is equal to 4a. Dividing both sides by 4, we would get that the value of a is 3. And so since the value of a is 3, that allows us to say my function in the end, take that, put that all the way back up here. In the end, my function is going to be f of x equals 3 for a times x minus 1 squared minus 5. Again, the -1 and the -5 were filled in from the vertex. The a was filled in once we used our x and y coordinate, plugged them in, and solved for it. Okay? And that's the function that satisfies this information. Nice. Hopefully that made sense. Yes, hopefully getting that. Let's do another one, kind of just like that. See if it catches on a little bit. What if I ask you again, construct a quadratic equation in vertex form that passes through this vertex of -8, 1, and passes through the point of -6, -7. Again, that means that this is the vertex of the parabola, this guy right here, and this is just some random additional point on the parabola somewhere. Okay? Again, we're trying to build in vertex form, so I would start with my blueprint here, a times x minus h squared plus k. And we'd say, well, if I know the vertex, the x-coordinate of the vertex is h, the y-coordinate of the vertex is k, we can absolutely take those things and plug them in right off the bat, right? To say, well, my function should start by looking like f of x equals some unknown a times x plus 8. In order to get that x-coordinate of the vertex at -8, that would have to look like x plus 8, remember? Squared plus k, so plus 1. All right. Now, I don't know what a is yet, but I can use my point to figure it out because I'm given, once again, a value for x and a value for y, and I can take those and plug them in and say, well, that means that my output, my y, my f of x, -7 should equal a times -6 is our x value that works on this function, -6 plus 8 squared plus 1. See again how x just went in for x and y just went in for f of x, right? Our function output. Because we're given x and y. We're told that this point is on the graph. It's on the parabola. So that's why we're able to substitute it for x and y. Now it's just a little bit of algebra to figure out what a is. We'd say here that -7 is equal to, let's see, -6 plus 8 is 2. 2 squared is 4. So again, we have a times 4, familiar, plus 1. Writing this in a little more of a familiar way, we'd say -7 equals 4a plus 1. And this is just solving for a now. Algebra 1. Subtract 1 from both sides. We'd get -8 is equal to 4a. Divide both sides by 4. We'd get -2 is equal to a. And now since we know that a is -2, we can take that, plop it all the way back up there, and say that our function overall should be -2 times x plus 8 squared plus 1. All right. Hopefully that makes sense, and hopefully that doesn't seem too bad. Hopefully that seems like, okay, I get that. Use the vertex for h and k. That's what we've been talking about all along. And then it's just a little bit of algebra. Plug in x, plug in y, and solve for a. Not too bad. What if we now step it up a little bit to say, let's not give you the vertex, but let's give you some information kind of related to the vertex and see where we can go from there. It's not too different, but I want to see how you can do with this. Ready? Let's do another one. My papers are all stuck together here. Here we go. How about something like this? Again, write the equation of a function in vertex form that has the following. We're going to say it has an axis, oh boy, of symmetry at x equals -3. We're also going to say it has a range, of -infinity to 6. And we're going to say it passes through the point of 1, -10. And again, our goal is to write vertex form. So although we're not given the vertex directly, right? That's the difference with this problem. We are certainly given some information that relates to the vertex, namely the axis of symmetry and the range. Remember, from the very start of all of this, when we looked at this problem here, the axis of symmetry corresponds with the x-coordinate of the vertex because it's this vertical line that's going to pass through the x-coordinate of the vertex. The range corresponds with the y-coordinate of the vertex because whether the vertex is a maximum or a minimum, that y-coordinate is going to be in the range. It'll be at the beginning of the range if it's going up. It'll be the last thing in the range if it's going down because that'll be the highest then, right? So using that information, we can go back to our problem here to say, well, even though we're not given the vertex directly, if my axis of symmetry is x equals -3, then that has to be my x-coordinate of the vertex, right? Which means that our middle part here would have to read as x plus 3. So I'd have to have f of x equals a times x plus 3 squared. Think of even if you just plugged in -3 for h. You would say, oh, x minus -3, that's going to be x plus 3. And our range, we just mentioned, is reflected in the y-coordinate of the vertex. So the fact that we're going up to 6 means that that would have to be our vertical shift. Has to be, right? Because the range and the y-coordinate are connected. So we'd be able to say here that this is plus 6. And that's how we can build with that starting information, even though we're not given the vertex directly. It's very clever, actually, I think. So that's cool. I like that. Now we're back at the same point we were before, where we can say, hey, I don't know what a is, but I can certainly find what a is by saying f of x should equal a times x plus 3 squared plus 6. We're given a value for x and a value for y that are on this parabola. Here's my x. Here's my y. Let's take that and put it in there. Let's take this and set it for my output. And we'd be able to say that that means negative 10 is equal to a times 1 plus 3 squared plus 6. And let's see what we get by doing all of this. This would tell us that negative 10 is equal to a times 1 plus 3 squared is 4 squared, which is 16 plus 6. Don't panic from the big number. Notice how this is going to work out. Writing it in a little more of a familiar form, we could say negative 10 is 16a plus 6. Two-step equation from Algebra 1 now. Subtract 6 from both sides. We would get negative 16 is equal to 16a. And divide both sides by 16. We would get that negative 1 is equal to a. And since we now know that negative 1 is equal to a, that means I can take this value for a, plug it right back up here, and get that my function overall is, so I'm going to take this, plop it right back up here, and we'd be able to get my function is negative 1 times x plus 3 squared plus 6. Okay? So even though we weren't given the vertex directly, again, we could use information about the vertex, information related to the vertex, to figure out what it actually is. All right? Hopefully that made sense. Let's do one more kind of like along those same lines, and then we'll be good for the day. One more problem. All right? With my bootleg camera setup. I really should take a picture of this. I actually will. I'll take a picture of it and post it on Classroom because it is almost comical. Like it's super bootleg and ghetto. My phone duct taped to the monitor to serve as a camera, but it's super cool how it's able to cast to the monitor over my Wi-Fi network. I'm like, this is so exciting. This is awesome. All right, let's do it. One more. We got example. Let's say the axis of symmetry. Go with that again. Is x equals 3 for this parabola. We're going to say that it has a minimum at f of x is equal to negative 8. And we're also going to say that this parabola passes through the point of negative 1 comma 8. Okay? So we're again trying to construct a parabola equation in vertex form given that information about it. What parabola, what equation in vertex form has an axis of symmetry of x equals 3, has a minimum of f of x equals negative 8, and passes through the point of 1 comma 8. Not given the vertex directly, but given a lot of information that relates to it. Starting with the axis of symmetry. We know the axis of symmetry is the x-coordinate of the vertex, which ties into the horizontal shift. If the x-coordinate of the vertex is 3, then that means the inside of this parenthesis would have to look like x minus 3 squared. If this parabola has a minimum at f of x equals negative 8, well, you know that that has to be the y-coordinate of the vertex, because the vertex is the maximum or minimum value of a parabola. It's right in the middle. It's going to be the highest or lowest that the parabola ever goes. In this case, the lowest, because it's a minimum. So we'd say at the end here that this is a minus 8. And now it's a matter of using the x and y to figure out what our stretch, our a value actually is. So let's do that. I would say my function so far is a times x minus 3 squared minus 8. Here's my value for x that I'm given. Here's my value for y that I'm given. My value for x will go right there. My value for y will go right there. Let's make it happen. We would say that 8, that's our y, our output, would equal a times negative 1 minus 3, because we're saying when we plug in negative 1, this is what we get, squared minus 8. Let's work this out. That means 8 is equal to a times negative 1 minus 3 is negative 4. 4 squared is 16, kind of just like we saw before, minus 8. Rewriting this in a familiar form, we'd say 8 is 16 times a minus 8. Let's add 8 to both sides to get that 16 would equal 16a. And then dividing both sides by 16, we would get that a is equal to 1. So that's nice. It just has a stretch of 1, meaning we don't really even need to write anything over here. But taking this and plugging it right back up here, we'd be able to say that my function in vertex form is 1 times x minus 3 squared minus 8. And that would be the function that would satisfy those conditions. All right? And that's exactly how you can use information about a parabola to construct its equation. Okay? It's even when you're not given the vertex, because usually the vertex is like the key non-negotiable piece of information, but even when we're not given that, we can find it if we're given stuff related to the vertex. All right? One last note that I think is important is the fact that if it were asking you to create the equation in standard form as opposed to vertex form, one easy way to do that is you could create it in vertex form just like we did here and then go through the conversion process to write it in standard form. All right, so hopefully that made sense. Please try to go back and review if it didn't. I think, again, it's really important to understand the connection between the horizontal shift, vertical shift, vertex, axis of symmetry, maximum, minimum, range. All of these things are connected, and I think this topic kind of puts a nice ribbon around all of that stuff, puts a nice bow on it to sort of wrap it up in a nice knot. Okay? But, again, thank you so much for your attention and focus. I don't want to take up more of your time. I hope you have a fantastic rest of your day. Please try the practice problems on Google Classroom, and I'll see you next time. Take care.